Hi, U.S. Army Rail Operations Field Manual 4-01.41. Rail out U.S. Army Railroad Rail Operations. Chapter 8 Railway Equipment. Effective, adequate transportation rail support of the military operations in a theater of operation requires the efficient use of the railway rolling stock and motive power. The training master reports or any misuse of rail equipment facilities of shipping activities through the rail unit chains of command of the commander responsibility for loading and unloading. Commanders must ensure the railway rolling stock is properly loaded, unloaded, and released in the rail units. Equipment use. Passenger equipment is frequently limited to the troop movements, leave to trains, and military casual personnel terms, trains, and ambulance trains. Special equipments include special designed rolling stock for handling unusual cargo, railway work equipment, ambulance cars, and if Army ambulance cars are not provided in theater operation, passenger equipments may be converted to ambulance cars. 8.2. When volume permits, containers and refrigerators, tank cars are handled in solid trains and given the high movement priority for the origin designation and return. The increased use of the containers of the movement of the military cargo provides throughput services to consignee. The containers show ship may receive a high movement priority for the original destination consignee. 8.3. When trains are exposed to enemy ground on air attack, engines and should be modified to provide increased armored protection of the cargo passenger security elements. Armored trains may be successfully created for use of security forces in support of the operations contested areas of the railway route. Rolling stock. The worldwide inventory Army-owned rolling stock includes locomotive cranes, tank cars, freight cars, and miscellaneous types and other equipment. It includes enormous diesel-electric locomotives stored in the use of various parts of the world. Most of the large locomotives are designed for the foreign, domestic, and are equipped for multiple gauge tracks, which can be adjusted to any of the gauge from 56.5 to 66 inches. Usually, the change in wheel gauges to suit overseas requirements are made in the Kanas, where wheels presses are available. 8.5. Contingency operations might require supplemental railway movement, motive power, rolling stock materials. Local equipment is even inoperable when likely inadequate to support transportation requirements of the U.S. Allied forces under the wartime conditions, the Army multiple gauge fleet storage and used in Kansas, other parts of the world. The basic source of the supplementary items pending in the establishment procurement of the program. Many countries which are potential areas of unrest are served in narrow gauge railroads. Equipment in these areas are in poor condition. Locomotives, freight cars, and are old and need repair. Locomotives have low tractive effort, and cars are consistent, largely boxed and flue flat cars, while low carrying capacities. These countries are often have insufficient railroad facilities to serve the economic needs, superimposing fast-moving, hyper-density military tonnage will exceed local operating capabilities. The Army has developed procurement specifications, narrow-gauge railway equipment to meet the operating characteristics, rail lines, and contingency areas. Railway equipment characteristics are shown in Table 8.1 and through 8.11. 8.1 is an extract from the official railway register. Okay, you see the type, the diesel, electric, or the locomotive itself. Its gauge that it carries on, and the weight of the poundage for the tonnage of the diesel, electric, or whatever model it may be. Length of couplers, extreme width, extreme height, and starting at the adhesion, and continuous tractive effort at 75% starting at the 75,700 pounds at 30,000 adhesion speeds, 30% adhesion speeds, continuing at 850 at 10 miles per hour. Horsepower is ranged from 1,000 to 231, and full capacity of the gallons is 1,600. You see more diesel electric locomotives with their tonnage and their Lewis model, and whether they're domestic or not, following the gauge, their weight, the length of the couplers, extreme width, extreme height, starting adhesion, contingency of tractive forces, and curve minimum radius, feet, and fuel gallon capacity. Some more on the locomotive cranes. This shows the gauge, the weight pound, the length of the couplers, the height, extreme width, boom length, and radius of the capacity, main hoist, and auxiliary hoist. 8.3 is a characteristics maintenance for motor cars. Gives you the gasoline gauge width and length, height, capacity, horsepower, and fuel capability. Those are cars. Open top cars are gondolas, hopper cars. Characteristics of flat cars. Characteristics of box cars. Characteristics of tanker cars. Characteristics of refrigerator cars. And Table 9, characteristics of special purpose cars. Characteristics of German freight cars. These are out of the official railway register. Characteristics of Korean freight cars. Okay, this is the Department of Military Traffic Management Command in Washington, D.C. 20315, reporting marks the ACI DODX 158. It shows that shows the numbers, the AAR type code, the AR number to design, the Lionel, the description, the dimensions, the meters, the weight and length and height and the door size and capacities. That's out of the DoD military railway fleet cars, extracted from the official railway equipment register. Staying here with the Department of Defense Military Trafficking Command, Washington, D.C. 20315. Characteristics out of the DoD military railway freight cars extract from the official railway register, equipment register. Locomotive classification. Locomotives are classified according to the wheel arrangement. The two systems are used in the Wyatt or the Continental classification. The Wyatt system. The system is generally accepted by the Great Britain, British Commonwealth, and North and South America. The Army used the Wyatt system to classify the steam, diesel, electric locomotive. Locomotives are grouped. Leading, driving, training wheels, numeral, separated hyphens. Separated by hyphens representing the number of the wheels in each group. Starting at the front end of the locomotive, the figure represents the number of leading wheels, and the second represents the number of the driving wheels. The third number of the trailing wheels, using the figure 3 if there is no leading or trailing wheels. The tender wheels are not included. The weight distribution is diesel electric locomotive is different from the steam locomotive. This is because the diesel has no tender leading trucks or trailing trucks. All wheels of the diesel electric locomotive are driving wheels, and the locomotive weight is evenly distributed on the driving wheels. 8.8. The wheel arrangements of two locomotives using the Wyatt system are often found in Figure 8.2. Since the wheel arrangement represents the side view of the locomotive, only one wheel of each pair of the shown in 2.8.0. The locomotive shown in the two leading wheels and the 8 coupled with driving wheels as no trailing wheels. 0660 diesel electric locomotive is shown in the driving wheels at the front of the trunk, axle 6 and rear and truck assembly. No leading wheels and train wheels. At the pulling capacity of the locomotive is directly related to the number of the driving wheels and drivers and the amount of the weight of the rest on them. Okay, the amount of the weight the rest on them. The leading wheels, the couple driving wheels, as you see in the T800 steam locomotive, a couple driving wheels in the front truck, rear truck, 0666 diesel electric locomotive, Wyatt system wheel arrangement to a locomotive. The amount of locomotive weight the rest on the drive is expressed by pounds and shorts of the 2,000 pounds on each. All tension mentioned on this text show are the short of tons. Therefore, the turns of the ton and the short ton are usually interchangeable. The distribution of the weight on the drivers differ from the steam and diesel electrical locomotive. The importance of the computing the traffic effort is the weight of the distribution of the 280 steam locomotive tender is shown in Figure 8.3. The locomotive and the tender weight of the 296,000 pounds over 350, but only proportion of the total weight of the rest of the driving wheels at 141,500 pounds affects the work capacity of the pulling effort of the locomotive. On the diesel locomotive, the weight of the locomotive is evenly distributed over the wheels since all wheels are driving wheels. Here you see the leading truck with wheels, 50,000 pounds, coupling the driving wheels with 1,450 pounds, and a fully tender loaded at 13,550 pounds. Weight distribution of the 28000 steam locomotive. The Continental system, the system commonly used in Europe and other parts of the world. The use of the letters and figures to identify the diesel electric locomotive by its axles. Letters, driving axle numbers or non-driving axles. In the system, A stands for the one driving axle, B stands for 2, 3, C stands for 3. and D stands for 4. A small placed O in the initial letter shows the individual powered, and therefore the single locomotive of the two individual powered by the two-axle trucks would be classified as BO, which means for two small placed initial individual powered locomotives axles. So there's two axles and going, they're both powered. One of the three axles and with the center axle idler would be designated as an A1, A1, A1. Types of railway equipment. The three basic railway equipment of the passenger freight, and especially each type of the equipment, is discussed below. Passenger equipment. Passenger equipment is to transport personnel. There's several different types of the passenger, each designed with a special core purpose. Each of the coach and sleeper cars, baggage cars, diners, and passengers can be modified to have no medical patents and power moved by designated ambulance freight train. The freight equipment. The freight equipment is primarily the movement of the general cargo commodity due to be moved. Dictates the type of the freight car that will be used. The 812. The examples of the most common the freight equipment of the domestic and foreign is shown in Figure 8.4, the 8.5, and 8.13. The least freight equipment by category used by by U.S. forces. Table 8.12 is examples of railway equipment, boxcar bulk items, weather and theft, and paper, electronic gear, and medical equipment. Flat car bulk protection from the environment is not the factor, although they will not fit on the freight car, the vehicle's connects, and containers oversized load. Gondola bulk item protection of the environment is not the factor, although that has keeping loading the shifting connects, the field barrier, multiple skirt. Hopper cars, free-flowing solids that need protection from the environment, gravel, coal, sand, grain, chemicals. Tanker cars, bulk liquids, POLs, chemicals, water, beer. Refrigerator car, its item needed constant temperature, either cool and warm, environmental warm, and cold environmental perishable wood, whole-blooded electronic equipment. Here you see the boxcar, flat car, gondola, tanker car, and the hopper car, domestic. This is a version of the freight equipment foreign services. You see different type of flat belly cars with a piggyback and a non-fish belly. A single axle flat car with one with a guard on it, and double axle and triple axle flat car. Examples of foreign cars, table. Special equipment. A special equipment consists of a locomotive, weight cranes, wreck cranes, snow plows, and shows the special equipment used in the domestic foreign services. The locomotive domestic services railway push wedge type of the car mounted at 56.5 inches and 60 inches of 1,520 centimeters gauges. A wreck crane foreign service. The locomotive domestic services. Car opponents. The transporter must have a basic knowledge of the car opponent. The rail operation have the knowledge of the car opponents. The four main components of the freight car are deck frame, deck, underframe, truck, and coupler. 8.6. The deck is the surface of the work of which the load rests on. The deck of the floor is usually steel or wood. 8.17. The underframe of the structure of the deck supports the weight of the load. Figure 8.7 shows the topside, underside views of the underframe. The body bolster, the center sill cover plate, the floor stingers, the body bolster with the state pocket, side sills, and draft gear and end sills on the belt both. Following with diagonal braces on the end sill, side bearing, body bolster, string supporters, cross bearers, center sills, and body bolster, and each on the other end. The truck is assembly which contains a car, wheel, axle, journal, suspension system, and braking system showing all components of the work in Figure 8.8. Here is a picture of a truck coupler. It starts. We'll start at the 11 o'clock hour and go around. Brake shoe, brake hammer, brake level, center plate, axle, side bearing, bolster, coil, spring side, spring plank, side frame, journal box, bottom conducting rod, brake pin, braking beam, rail, and wheel. 8.9. The coupling device connects the couple with another car, and an automatic knuckle couple is used in the Conus military railroad hooking link and system of the Europe, the Euro coupler. The two advantages of the hook and link system are the automatic coupler is stronger, allowing heavier trains, and it also safer. The automatic coupler does not require a train man to step between the cars to couple them, but hook and link coupler does. This is the automatic coupler, the knuckle and the pin, and the knuckle and the shank. Effective as cold water, multiple motive power, and rolling stock. In the past, steam locomotives were used successfully as railroads operating in cold climates. Most of the world's railroads have adopted diesel because of certain advantages over the steamers. However, certain modifications have been made to both of the types of locomotives before they are entirely suitable in extremely cold weather operations. Steam locomotives, even the efficient steam locomotives operation depends on local supply of fuel, water, standing, and facilities suitable points along the line. Coal platforms constructed with the bed level with the top of the tenders platforms have been used without great difficulty, resulting in the cold temperatures. Water tanks must be kept full, heated all winter. This does not mean this is done with steam pipes which encircle the entire interior of the tank in the on climate, having the winter temperatures as low as 40 degrees Fahrenheit and sand wheels from the mostly through the dried. Installation personnel will insulate exposed water pipes to keep them from freezing. Exposed streams of the pipings, preventing the heat and loss of locomotive cabs and the extreme, especially insulated on steam heated and passenger cars. Cover windows at the night in the blankets to keep them extremely cold, keep them out of the extreme cold. 823 standby services. When steam locomotives are used, engine watchers must be provided. Watchers must use fire up to the engines, keep up the pressure. Must put water into the boilers when first moving the steam locomotive. The cylinder cocks always open to beneath the cylinder. Extremely heavy condensation. An average winter climates, one watcher may tend as many as 10 locomotives in cold. When the climate's number of the locomotives for each man to be reduced with a great variety of duties. Duties consist of continually operation checking the following: the stalkers, the boiler, blow-offs, the injector cylinder cocks, and lubricators. Reverse levers, particularly screw reserve types, have been operated frequently to protect against freezing water leaking out of most of the corrode. Any water leaking parts that move the corrected ones have been prevented by the ice forming when placing the locomotive inside the heated roundhouses. Engine houses substantially reduced the standing by services. Diesel electric locomotives are required when considering standby services. A steam locomotive in the extreme cold weather, the problem with the water supply is virtually eliminated. However, before using the diesel in the sub-zero temperatures, the following modifications: insulate the outside piping to protect any freezing. Preheat the fuel because of the extremely difference between the unheated fuel and the flashpoint instant heater. The engine compartments keep the engine coolant warm to aid the starting of the locomotive under extreme conditions. Under extreme conditions, the locomotive must not be shut down unless engine block heaters are used. They keep the storage batteries responsibly warm to secure the maximum output. Place the coil in the pipe around the battery boxes through which the saline water flows. Small steps of the generator must be provided to heat the cab and the passenger coaches. Install extreme insulation in engine cabs. Window cars and passenger coaches should have sealed, airtight, double thickness and glass and to keep out the cold. Rolling stock. One of the greatest problems encountered with the cars in the freezing journal when the car is any length of the time the journal box is freeze so tight that the wheels are instead of turning on the attempt is made to be moved. Sometimes the train of 20 cars has been stationary for even a few hours. Will have to be broken in 3 to 4 sections, in each section started individually. After moving the cars in short distance, heat generated by the axle on a bearing warm through all journal on the condition naturally delay. The operation can only be overcome by the moving of the cars and the train as much as possible. Cars equipped with the roller bearings and the less problem. Extremely cold and cause the steam cars to become so brittle that they break easily. As a result, the knuckles must be broken in the cars, which each of the drawbars pulled with when frozen trains are started. When possible, cars should be switched as soon as they can come into the yard, and while the journal box is relatively warm, the trains from the main tracks or sidings should not be permitted to remain stationary longer than absolutely necessary. Chapter 9: Wreck Crews and Equipment.